Welcome everyone. Today is the introductory lecture on the course, the engineering course we offer, titled Introduction to Robotics. As in the past, what we have mentioned, that kindly do pay attention to the keywords in important titles, the course we teach. In this case, robotics is the keyword. Anyone interested in the history of this word, kindly click on the link and you can find these slides in the description where the video is posted. Okay, so let's carry on. So we have a Quantic Field Institute um, under which we offer these courses. Soft Galaxy Technologies Inc. is an affiliated organization, and the best website to see what we do and what services we offer. Kindly visit the LinkedIn, very popular professional website, this particular link to find out the details. One of the most important things that we believe firmly on is this particular quote, that there is no shortcut to glory. Any particular area of learning, um, you need to work hard, you need to be smart, and the time will tell the success story to the path you opt for. Okay. Any questions? Anyone interested in taking these courses we offer? Kindly send an email to info@hsclouds.org or softgalaxy.hsclouds@gmail.com. And here HS stands for Humanity Serving Clouds. That's what it means, HS Clouds. Okay. So this particular course, one can expect the following objectives: that you will be taught the basics on robotics, different types and the building blocks, designing a robot for industrial applications. So this is not you should not expect this as a basic engineering course. Taking this course requires kind of prerequisites, highly recommended before you enter and take this particular course. So let's move on to seeing that even though we know robotics keyword globally very well, but I think it's important that how robotics can um, the, the products of robotics are how they are serving humans globally, and achieving efficiency in their workflow. So let's look into this. Amazon's or Alibaba's. So let's look into this YouTube video. So here you can see it's an Amazon fulfillment center. The orders. I'm just going to give a high level, a kind of an overview on all of these videos, and I really appreciate when you revisit the slides which is already shared with you in the link description below. I appreciate that. Please go and watch the video in its entirety, which will give you a lot of information relating to this particular course. As you can see here, face recognition systems, and what I want you to show that once the order comes in, so these are the products coming into the warehouse. And so see, these are the robotics. You see their movements? That's amazing. And all of their movements So we will discuss how these robots, move these, racks into one particular location. So it's a combination of obviously many systems, and we will discuss that how or how such a system can be designed, you know, in this particular course. Okay, so that's what I wanted to show you. And anything else in this particular video? Yeah, so as you can see here, automatic labeling, that's on the boxes, the destination addresses, and before it goes out to the warehouse, or here we go. So there it goes out for shipment to the destination. So that's amazing example when we discuss robots. Let's talk about these tiny robots. Seems like a slow connection of internet. I'm extremely sorry on that. Why not while it's loading, I will try to load some of the other videos as well so that it can save me a lot of time. So this particular video shows the tiny robots which swim through the eye to deliver the medicine. So see the power of this particular area of research and learning, how it can improve human lives. Okay. So the idea is we want to have a vehicle like a robot where they can use it the way they want to use. It's 500 nanometer of size, kind of a bot, as you can see, moving at the will of the doctor. And so such a tiny object, we call it as a robot, uh, and it's a combination of electromagnetics, which basically helps doctor deliver um, those bots go to the destinations to deliver the medicine inside human eyes. And yeah, so just to show you that robotics can't be that big as we see in nowadays life. It can be so tiny that you have to that you have to see under a very good microscope. Okay, let's move to our next example. So see this robot from Boston Scientific. I really love it. As you can see, like see the balancing, the jumping, and all these acts. That's a really complex job to design a product like this, and that involves, uh, you know, several, teams to work together in order to make this particular product. That involves mechanical engineers, electrical engineers, electronic engineers, computer scientists, and product managers, designers. So, but in relating to this particular course, we expect, because we are going to cover the knowledge behind designing such robotics. So we expect to have a very strong preliminary course requirements met by the students because you need to have a clarity on how to program microcontrollers, microprocessors, DSPs or FPGAs, on how to work with these. You need to have an understanding about digital systems, C, C++, Python, or languages like this. So here is another example, and it's a factory using robotic arms for their welding work. So spot welding, as you can see here. So all of these robotic arms are basically doing spot welding in an industrial environment. Let's go to the next example. So this particular example is for a grocery store with no customers coming in. So the customers place their order using their app, and through the app, the orders the company receives, uh, these bots. Hopefully, it can run. Just give me a minute. So once the order comes in, these robots fulfills the order, and what you see in this particular grid, there are grocery items in every bucket, and the system that they have designed is basically fulfills the orders and send it to the. So here are the tiny robots used for this particular purpose. Okay, let's carry on. So this is a mail sorter robot. Let's see how it works. So the entire job, see amount of mail coming in, and to properly sort it out, it's they have designed a system of an automation system. So here's your mail sorter robot, which basically sorts the destination where the envelope should go. Okay, that's the mail sorting robot. These robots are used for waste management. So let's see how it works. We're just trying to just see. So in one of the companies I met, so what they do, even before picking up the waste from the bucket, they have cameras which can basically quickly identify the percentile of the type of waste inside that particular waste bucket, and based on that information, they can decide which truck should come and pick up that particular waste bucket. And as you can see here, it's a robotic arm utilized to separate plastics from the rest of the waste. Okay. AI, artificial intelligence, and machine learning has to do a lot in these actions that you just mentioned. Okay. So these are microscopic robots like the one we saw previously, delivering medicine to the eye. But in this case, it's a microscopic robot with legs, which can be utilized for the desired purposes. And what is the desired purpose? It's, as you can see here, here we go. Again, it's electromagnetics, and because of that, the doctors can maneuver that robot inside human bodies wherever they want that to operate in order to achieve their desired objectives. So the one you saw before was historical development of that bot. It doesn't have legs, but this shows that this particular bot can be maneuvered much more precisely than the previous one. As you can see, this has legs, and it can basically help doctors and other. It can be used for numerous other applications in order to achieve desired objectives. Okay, let's move on. And this is again a robotic arm, to lift heavy weights. Here's a cool robotic, you know, to place packages from A to B. Here's what we have already seen: waste management. These are one of the top 10 applications robotics are utilized. And again, I highly recommend all of the students to watch these videos in its entirety to get a clear understanding about how the robots are used in industrial and commercial applications. So this is Boeing's warehouse, not the warehouse, Boeing manufacturing plant, and this is the robot they used for highly accurate, um, you know, purposes when it comes to working with wings. That requires a very high precision, and that's what they do. Use that robot right behind this gentleman. They put up the wing inside that opening, and after it's prepared, again, it's a quality check they go through. So as you can see, the robots really help us a lot in industry and in our daily lives, improving lives in general. So in this particular course, here's the distribution of works. As previously, if you have taken any of the course, you know that a lab work which will be given to you will be part of the assignments, which is 10%, and the testing will be 5% before the midterm, 5% before the final of the distribution of the assignments marks. The lab work, you will be tested in person on the day of midterm, on the lab work, which is basically assignments plus lab work, and on the day of the final, 10% of the day of the midterm, and 10% before the day of the final. And in between, you have a half an hour or 1 hour break before your midterm and final, before the lab work. Assignments will be given to you to test your skills, hands-on skills. Midterm is 30% and finals is 40%. We have planned 4 industrial visits in order to enhance our objective to give you hands-on and industrial practical knowledge relating to this particular course. Okay, so let's carry on. So let's have a formal introduction of what a robot is. Many definitions have been suggested for what we call a robot. The word may conjure up various levels of technological sophistication, ranging from a simple material handling device to a humanoid, as we have just seen in our demo videos. The image of a robot varies widely with researchers, engineers, and robot manufacturers. However, it is widely accepted that today's robots used in industries originated in the invention of a programmed material handling device by George C. DeWall in 54. DeWall filed a U.S. patent for a new machine for part transfer, and he claimed the basic concept to program control the device. And here's the look of George C. DeWall's robot. Okay, and you can click on this link Unimate in order to read the relevant associated details. because such a word has to be there once we have kind of computers, which is in the 90s, and related technologies before someone can even envision a device like this. This scheme is now extensively used in most of today's industrial robots, which is we just saw in our YouTube videos. It's basically a robotic arm. Okay, let's carry on. George C. DeWalt's industrial robots have their origins in two preceding technologies. Numerical control for machine, it's a scheme to generate control actions based on stored data, may include coordinate data for machine movements, clock signals to start and stop operation, and logical statements for branching control sequences. The whole sequence of operations and its variations are prescribed and stored in memory. So everything, that's what the memory has all you say the kind of information, data of actions, so that the different tasks can be performed without requiring major hardware changes. Again, it's a programmable robot, and it can be utilized for different purposes. Remote manipulation, like a hazardous environment, for example, again, just as an example of where the robots and how the robots can be used. So this is a Jet Propulsion Laboratories planetary exploration robot, Mars rover, and you see what it's doing. It's basically have the data, center data, and it performs it builds the map just like this to estimate the location where the robot is at a particular given moment of time, and then it basically performs the control of the robot on the forward or the movement of robot forward, back, sideways, whatever it is. Okay, just as an example to how the Mars rovers bots work. What are some of the key parts of a robot? Let's look into that. But as seeing it, I think you must have identified. But let's see that in this particular slide. So obviously they required a source of energy source. Motors, because all the motions when you see wheels, arms, legs, maybe a robot having a face. So all those motions requires a lot of, and the motors are utilized for those motions. Obviously sensors, to detect their surroundings. So the sensors are heavily utilized in robots or robots manufacturing. Switches again to make things on and off. And as mentioned before, the very strong kind of a decent knowledge on microcontrollers, DSPs, FPGAs, microprocessors, and associated intelligent electronics is the kind of knowledge which is required before it is encouraged for you to get into this particular course. And so here are the type of motors. You can have a DC motors or AC motors, brushless, brush motors. So we will discuss different type of motors and how they function in this particular course. Not the whole lot in detail, but a high level overview is kind of an expected for students to have knowledge on when trying to work with designing or working with robots. These are the electric motors, AC motors, DC motors, and special motors, and we will discuss as we go along and progress in this particular course. Yeah, so here which shows, I think you must have seen that in your basic of physics course, sciences courses, that because that is the primary fundamental law of physics, that a current carrying wire um, basically, surrounded by a magnet generates a force in this direction. If the current is flowing in this direction and the magnet is placed like this, the force will be generated in the upward direction. Also, you can envision this as a right-hand rule. Mechanical force produced by a current carrying wire in a magnetic field. That's exactly what the scenario happens. And here what it shows, like if you have a magnet like this, the lines of forces, which direction they go from north to south pole, and here are some of the basics of relating to a magnet. So basically, if you just place a magnet on a surface and you try to monitor using a compass, the line of forces, that's exactly what you will find out. Okay, let's carry on. So in this slide, we are discussing commonly used sensors for achieving robotic features, functionalities. It's showing that for simple touch, sensing the object's presence or absence, complex touch, sensing an object size, shape, and or harness, simple force, measuring the force along a given axis or a single axis, complex force, measuring force along multiple axes, simple vision or detecting edges, holes, and corners, and complex vision, recognizing objects, proximity, no contact detection of an object. Sensors can measure physical properties such as the distance between objects, the presence of light, and frequency of the sound. They can measure object proximity, physical orientation, heat, chemical sound. So what we are trying to show you in this particular in a slide information given to you. So the what type of sensors, what type of components are required when it comes down to building a quality robot for a particular application. Okay, so it's as I mentioned right in the beginning when we saw the Boston Scientific humanoid style robot jumping around, with ease, and you know that's really a amazing video. But behind that quality product goes a lot of engineers work, a lot of companies utilize in relation to all these keywords discussed in this particular slide. Okay, so let's carry on. And here, like some symbols, switch symbols are shown here on this slide. Single pole, single throw. Uh, it's a pole, single throw. NO for normally open and NC for normally closed. It means when you're going to use a switch like this, default position is normal close, as you can see here, and here the default position is normal open. Single pole double throw, as you can see, it has a single pole, but it can throw on two poles, one and two. Okay, and it has enable line. So in order to, if you're working with a switch like this, which is single pole double throw with the enable line, it means the enable line has to be enabled before this you can utilize this particular switch. Again, it's a safety thing, and for many applications, engineers use just to achieve their desired objectives. And this is a single pole double throw without an enable switch. It's a single pole triple throw, as you can see, 1, 2, 3 with an enable line. Single pole single throw twice. There are two switches. Single pole single throw two times. Normal open, normal open. Oh, I think this is wrong. This is normal close. This is normal open. So this is a typo. When you're going when you read books, papers, and please do expect that people are, the humans do make mistakes. So, and the only thing that the best you can do is to be, like report those mistakes to the publishers or paper publishers, so that they can inform the author in correcting such errors. Okay? So again, it's a two times single pole double throw, a double pole double throw. Okay, two of those. It has double pole, double poles which can switch to double locations, and double pole double throw. Kind of two of these, and physically they look like these. These are their schematic symbols. Okay, so these are push buttons, like single pole, single throw. These are slides, slide switches. These are dip switches. Yeah, we will discuss on these as we go along in designing and working with robots. Okay, so as mentioned right in the beginning, because when we talk about these smart robots, use of microcontrollers, microprocessors, DSPs stands for digital signal processors, and FPGAs, especially when it comes to deterministic response time of a robot or bot. FPGAs are heavily utilized because they can do the job very well. But again, for other purposes, the computing requirements are not that intense. You can use microcontrollers or microprocessors. DSPs, DSPs and FPGAs. You can think those as very heavy, kind of powerful computing engines. And when we use these, we're talking that we are dealing with deterministic response. We are working with high computations like image processing and so on and so forth. Okay, so that's you can see here. We are working with complex ICs, DSPs, and FPGAs or microprocessors, and I'm just showing you here different packages with such an IC. This is a pin grid array. And this is quad flat pack style IC, and their dip styles. Anyhow, so our DGs are popular packaging schemes because they take less area, and in delivering an IC which can be placed in achieving smaller PCB. PCB stands for printed circuit boards. Okay, let's carry on. So this particular table shows the comparison of typical microprocessor FPGA ASICs. ASICs are primarily, you can think that this as uh, they're they're like they're integrated circuits which are application specific. A as for application specific integrated circuits. So these are, when a certain functionality of a of a digital requirement has been tested thoroughly, and the companies, because they want to produce that in in mass quantities, they normally opt for making that particular design into an ASIC, and that those ASIC ICs are also popular again, as I mentioned, for mass applications, serving so ASICs are utilized for such purposes. You can consider them as FPGAs are reprogrammable, but in ASICs they aren't. So here in this particular table, we're just making a comparison of these. I'll call it as compute engines, because GPU is a graphical or graphics processing unit. Um, so let's see how we can compare these compute engines according to these particular features. So flexibility during development, flexibility after development, parallelism, performance, power consumption, development cost, production setup cost, unit cost, and time to market. So in microprocessors, when we talk about microprocessors, so all those, that's how they are compared in relation to these parameters. FPGAs, as you can see, they are very high in flexibility during development because they are reprogrammable. Um, Flexibility after development is high, and as you see, after development is slow because they're application specific. Parallelism is high in both cases. Performance is medium, and in this case is high. Power consumption, this depending on which FPGA you're working with, it can be high. In ASIC case, it's low, but I think both can be very high, like the case in microprocessors and GPUs as well. Development cost is for microprocessors, which is the most important factor, is low. FPGAs is medium and can be high depending on which FPGA you're working with. Similar is the case with ASICs and GPUs. The development cost can be low. Production setup cost, as you can see in the case of ASICs, it can be high because the companies have to make a special order for IC manufacturing in order to manufacture the ASIC, but there is no cost because they're all generic application, general ICs, IC manufacturers produce. Similar is the case with GPU. Unit cost, and I think nowadays the unit cost is, when we talk about microprocessors, microcontrollers, it's kind of, I should say, if we are not talking mass production, it's kind of irrelevant for smaller quantities. It's true for FPGAs as well, depending on what type of FPGA or what, kind of how complex is your design, it can be low as well. And again, so these are relative, kind of also. But anyhow, depending on at what given point of time you're working on and in making a decision on these parameters, these things can vary, okay, depending on the region and the international also status on all those production of these ICs in relation to these particular parameters. Okay, so let's carry on. As mentioned right in the beginning, there are the preliminary course requirements, decent knowledge of mathematics and physics, decent knowledge on programming microcontrollers, Arduino, Raspberry Pi. Hope, because this coverage of programming microcontrollers can help you, because when you understand some basic programming languages, how to program a given microcontroller. But it's beyond this, it is expected that you do understand the basics of digital electronics, analog electronics, C and C++. Okay, let's carry on. So this is one of the references we will be following along with others. We will add on as the course progresses. So here's the basic introduction on this particular course. Any questions you have, please do send us an email. And as mentioned before, that we will cover not only the basics of robotics, but we will try to cover every aspect of modern robotics design, use of AI and machine learning in the design, and all associated concepts in this particular course. Okay, thank you.